After 5 amazing years of Unity development and a ton of C# wizardry, it's time for a change. After surfing the web, forums, and talking to ChatGPT, it is time for a new engine, the Flax Engine. Hosting a ton of useful features and an amazing resemblance to Unity, it is the most likely candidate to take its place. Forget Godot and Unreal, and let's take a look at the Flax Engine.
Hello guys. Before we do anything with the health component, we need to reorganize the project a little bit. Now that we have the shoot component, we can go ahead and add it to the agent class, and of course modify the player and enemy classes also. So let's go ahead and do this. Let's go here to the agent class, and we can go ahead and add a public shoot component. Right. So now that we have this shoot component in the agent, we don't need anything to deal with the shooting in the player. So we can go ahead and remove anything shooting related. Right. We will leave the handle shooting, but we will remove everything else. Okay, so here inside the handle shooting, what we are going to do is go shoot component dot handle shooting, and we need to send in a boolean. So what we are going to do is to create a boolean is shooting, which is equals to input dot get mouse button left. All right, and we are going to send it in. So is shooting, and this will now handle the shooting for us. All right, awesome. We can also go ahead onto our enemy script, and we can remove the shoot component here, since it now inherits from agent. All right, awesome. So now we need to add a shoot component, and we can drag and drop it here. Let's select the projectile. Let's select the spawn point, and let's leave it as a free fire rewrite. Let's see if it still works. All right, awesome. So it is still working. The enemy is also still working. So this is the basic change that we need to do. All right. Another relevant change that we need to do in the shoot component is that at the moment we are just creating an actor called Projectile, right? He is completely standalone and independent, and we have no way to access it. And this has to change. So there are several ways we can access our projectiles. So one way is to add here a list of projectiles. So here we can go public list projectile and projectiles. Yeah. All right. Awesome. Let's indeed initialize it. So new list of projectiles. This will make sure it is initialized. And now here, when we are in the shooting state, instead of just spawning the projectile prefab as an actor, we want to spawn it as a projectile. So now once we have created the actor, we want to get the projectile script. Awesome. We of course want to add it to the projectiles list. So let's go projectiles dot add projectile. So now we have access to all the projectiles that were spawned here, but they are always added and none of them are removed. And we are also just having access to them here. Maybe we want to have access to a newly created prefab somewhere else in some other script. So what we need to do now is to add events. Events are basically actions or action delegates that you can use to send and receive information without a direct reference to a class. I have added here a custom event class, which is downloadable below, which is basically a part of the Unity events class. So we can basically add listeners to a certain event. We can remove listeners from a certain event. We can clear all the listeners that are listening to a certain event. And we can, of course, invoke the event /action. All right. I have also added all the types that are also in the Unity event, and you can take a look at it. So now, here in our shoot component, we want to add a new event. So we go public, read only, custom event of type projectile. and we are going to call it on projectile spawned equals new custom event of type projectile. The reason we have this as read-only is because we want this event to be present only in this class and this class only. And we do not want it to be modified by other external classes. So we have it as read-only and we immediately initialize it. All right, awesome. So now back down in the shooting, once we have spawned the projectile, we can go ahead and on projectile spawned, if anybody is listening, so we add this question mark, is anybody listening? If so, then dot invoke and send in the projectile we just spawned. All right, awesome. So this way we now have a direct reference to a projectile that has been spawned. We can now go back to the projectile and we can also add an event here. So we can go public, read-only, custom event. We are going to send in the projectile and we are going to call it on projectile destroyed. All right, we are going to, it is going to be equals to a new custom event of type projectile. And here we want to go ahead and when we are destroyed, so we can go public, override on destroy. We can call this event, so we can go on projectile destroyed. Is anybody listening? If so, we go dot invoke and we go this because this is the projectile that we want to send in. It was destroyed. Awesome. Back in our shooting component, we can go projectile dot on projectile destroyed, add listener. So now we are going to listen to when a projectile was spawned. Right, and we are going to add that method here. So we go void projectile destroyed. We are going to send in the projectile. What we are going to do is if projectiles contains projectile. We are going to remove this. So projectiles dot remove projectile. Awesome. And this method, it is going to be listening to this event. So when on projectile destroyed is invoked, this listener is going to detect, oh, a projectile was destroyed, and the projectile will be sent here, which we then process and remove it from the projectiles list. Awesome. We can take a look at the projectiles here, and we can see that they are added and removed to the list dynamically. Once they are created, they are added. Once they are destroyed, they are removed. All right, cool. Now we can go ahead and create the health component. Let's go back into our scripts. Let's go into component. Let's add a new health component. And the health component is going to have a couple of variables, none of which we should make public. So let's go serialize, show in editor, int max health. Let's make it 10. And we are just going to make another one called health. And a show in editor float health %, which initially is going to be 1. And another show in editor bool is dead, which will be false in the beginning too. Right, awesome. Let's go ahead and create our methods. First off, we need one to set the health and max health, and also both values. So we can go public void set health int health, and we can go ahead this dot health is equals health. Public void set max health int max health, this dot max health is equals max health. And we of course are going to need another one, public void set health values, which we are going to send in an int max health and an int health. And this dot max health is going to be equals to max health, and this dot health is going to be equals to health. All right, awesome. Now we can go ahead and create the damage properties. So we can go public void apply damage int damage health is equals to math f.clamp. We want to clamp this so that it doesn't go below 0, so we go health minus damage 0 and max health. All right. Let's also go ahead and create a public void apply heal int heal, which it basically can copy this over, and instead of decrementing, we can increment heal. So whenever we modify the health, we want to both send an event and also calculate the percentage. So let's create here a method called void health changed, and in this health change we go health %, which is equals to health divided by max health. We also want to send in the event, so let's create him here on the top part. So let's go public read only custom event. We are going to create one for int for when the health itself is changed. So on health changed is equals to a new int event, and we are going to create another one called public read only custom event float on health % changed equals new custom event, and of course another one that sends in both. So public read only custom events, we can send in the int and the float, and on health values changed equals to a new custom event. Exactly. Alright, so when health is changed, we want to send those events. So on health changed, if anybody is listening, we invoke it and send in the health. On health % changed, if anybody is listening, we want to send in the health %. And on health values changed, if anybody is listening, we want to send in the health and the health %. Alright, cool. We also want to make a check if health is less or equals than 0, we want to kill it, so we can go death. Alright, so let's create here a void called death, and on death we are basically going to say if is dead equals true, we want to return we're already dead, nothing to do, else is dead equals true. And we also want to fire here an event, so let's go public read only custom events on death, right, equals a new custom event with no types that we can sense. Right. On death, if anybody's listening, we invoke it. So now we can go ahead and apply the health changed wherever we change the health. Alright, cool. Another useful method to have is a method to either immediately kill or immediately revive this component. So we can go public void kill and public void revive. So in kill, we want to set the health as 0, and we can go and health changed. When we revive, we want to go health is equals to max health, and we want to call health changed. All right, awesome. Something that we aren't checking, and we should, is if we are dead, right? So we only want to apply damage to stuff that isn't dead. So if is dead is equals true, we want to return, nothing to do here, right? So we want to do that again in the apply heal, in the kill, and we don't need to send this in the revive. We can use the revive just to set the max health again. It doesn't need to be dead to be revived. Okay, cool. I think this is everything here in the health component. So now we can go into the agent, and we can of course add here a public health component. Now back in our projectile script, we can make some changes. We can add two new variables called public layer mask, and we shall call these impact layers. These are the layers which the projectile collides with. And we can also go ahead and create a public string array of tags, which we will call damage tags. And this will be actors with these tags will receive damage. Right? Apart from strings, we could have also set the tags as public tag, impact tags, for example. But because right now there is an issue with setting up tags in the prefab window, it is a known issue and it is currently being worked on. We are just going to use these strings because even though it's more error prone, it still allows us to do what we need to do. All right, awesome. Let's create here a header, impact layers, and here one for properties. Awesome, so what we are going to change next is here in the physics.overlap box, we want to add in the impact layers so that we only collide with the layers that we want to impact. Here, we are also going to process the collision. So we now can create a void process collision. We're going to send in a collider. And we are going to substitute this method with this debug. So let's cut and copy it here. Cool. Let's delete this and send in the process collision exactly like so. All right, awesome. So here in the process collision, we are sending in a collider actor, right? And what we want to do is to check if it has any of these damage tags, right? So we can go if collider.hasTag. Flax only comes with this hashtag, but I have added this hasAnyTag method, which allows us to check if there is any of the tags that we send in. So we can send in the tag struct or an array of strings. All right. So we are going to send in the damage tags. If true, then we want to find the health component, right? So the way we do this is we first need a variable to the health component. So we go health component health. First, we check if it is inside the collider. So we go collider dot find script. This will find the script inside all of the hierarchy. So we go find script health component. Awesome. If this is still null, we have to check for it. So health is equals null. Then health is going to be equals to collider dot find script in parent. This again is also a script that doesn't exist in Flax. I added it in this extension's static class. So let's go ahead and search for it in the parent. And now that we have checked for the health component both in the child hierarchy and in the parent hierarchy, we can go ahead and if health is not equals null, then health dot apply damage, and we send in the damage. All right. Something to take into consideration is that this might not be very performant. We might have a collider that, for example, has a skeleton or an armature as a child, and this will check all of the bones for this health component, and this might not be very performant. And also, this will also check all of the parents and parent of the parent and parent of the parent until it finds a health component, right? So in this case, because we know that the health component is always going to be in the parent of the collider, we can go ahead and change this. So we can go, this is equals to the parent And if we still do not find it in the parent, we are going to search for it in the children. All right. But take this into consideration when you are doing this type of thing, right? It's important. So now that we are done with the projectile thing, we can go ahead here into our projectile and set the impact layers. So we of course want to set the default impact layer, right? And this is the only layer that we are going to change here, right? The damage tags, we are also going to set as 0. We want to set the damage tags depending on who is firing this projectile, right? So we can go ahead and create new tags for the colliders. So here, the player, we can go onto the tags. I have already created this player tag, but to create a tag, you just go here, add tag, type in the name of the tag, and then create the add tag, right? So the player collider has the player tag, and the enemy collider has the enemy tag. And what we want to do now in these agents is that we want a way to set these tags here, right? So going back into our agent class, we can go ahead and create a new header, impact layers, and we can of course have here a public layer mask, impact layers, and public string damage tags. And when we fire, we want to send this information to our projectile. So here on start, we can go ahead and listen to when a projectile has been shot, right? So we go shoot component dot on projectile spawn, add listener, and we are going to create a new event called void set projectile properties, right? This will require a projectile as input projectile. And this method will be listening for whenever the shoot component inside this agent has fired a projectile. So now we can go ahead and projectile dot impact layers is equals to these impact layers, and projectile dot damage tags is also equals to the damage tags. All right, awesome. So let's take a look. Because we haven't set any impact tags in both in our player and our enemy, they are just passing through everything. All right, so we need to set them up. Let's go back here into our player, which we have forgotten to add a health component. Let's add it here. Let's go into our impact layers, and we of course want the default layer, and the damage tags, if you remember, we want the enemy. We want to damage the enemy. Here on the enemy, we want to do the same thing. He also doesn't have a health component. Let's add it. And here in our impact layers, we want to set in the default and the player tag. All right, let's take a look. So if we go here into our enemy's health component, we can see now that he is taking damage whenever a bullet collides. The player is also. So now we need to do something about that, right? So when health is 0, we want to do something. So now back into our agent, we want to go ahead and health component dot on death dot add listener. We want to add a listener to death. We go protected virtual voids death. And the reason that we are making this a protected virtual void is because not every component dies in the same way, right? Because we want, for example, for when the enemy dies, we want him to add some points or something like that. And when the player dies, we also want something completely different to happen, right? So here, back on the enemy, we can go ahead and override the death. So let's go protected, override death. And when we die, we just want to destroy this actor for now, right? And when the player dies, we just want to send in a debug.log player has died. So let's give this a try. If we check here the health component of the enemy, we can see that it is decreasing, and once he dies, it reaches 0, he dies. All right, awesome. Something relevant to mention is that here in the health component, whenever we have changed our health, we want to reset the isDead boolean whenever health is still above 0. I have forgotten to implement that before. You need to add this change. Something that is also a little bit annoying is that these, whenever we have an event, they are still showing here, occupying space in the properties window. And a way we can remove that, and we can add here an attribute called hide in editor, right? So let's go ahead and add this to all our events. Because it is annoying to be constantly changing the values from component to component, let's set all the major values in the agent class. So we can go agent, and here we can go public int health equals 10. Let's set the damage close to health, and on start we will go health component dot set health values, and here we are going to send new health and health. Something that I also changed in the set max health was this, in case we want to set the health as the max health also, which is also useful. And now back at the agent, when we spawn the projectile, we go projectile dot damage will be equals the damage. Alright, awesome. So now we can change everything here in the player. Cool. Alright guys, so after changing some parameters and moving enemies around, we now have a simple top-down shooter with the win condition yet to be implemented. So on the next tutorial, we are going to take a look at the custom assets, which is Flax's equivalent of the scriptable object. And we are also going to tackle animations, so you can look forward to that. I hope that you guys have enjoyed, and like and subscribe so you don't miss out. Peace guys, see you in the next one.